It starts with a single blink, a subtle movement, invisible to anyone else. But your glasses notice. They know what you're looking at. They sense when you're interested, distracted, or even nervous. And before you've said a single word, they already predict what you're about to do next. Sounds impossible, right? But that's exactly what's being developed right now. Smart glasses that can read and interpret your mind. From Meta's neural band, which detects electrical signals from your wrist muscles, to experimental prototypes that measure your brain activity through your temples. The line between technology that sees and technology that understands is fading fast. This isn't science fiction. This is happening right now. Let's start with the basics. Traditional smart glasses, like those from Meta, Apple, or Samsung, are already packed with sensors. They track your gaze, your blink rate, your head movement, even your voice tone. And every one of those tiny signals reveals something about what you're thinking. When your pupils dilate, the glasses know you're focused. When your eyes linger on a product or a face, they know what interests you. When your blink rate changes, they detect stress or surprise. This is what scientists call cognitive biometrics, data that reflects your mental state, and it's becoming the new frontier of wearable tech. Because the future of smart glasses isn't about what you see, it's about what your devices can see in you. Now, let's clear something up. No, smart glasses can't literally read your thoughts yet, but what they can do is get frighteningly close. Meta's neural band, for example, doesn't read your brain directly. It reads electromyographic signals, electrical impulses that your brain sends to your wrist muscles before you even move them. That means your glasses can detect your intention to move, even before you do. You think click, your finger twitches, and the glasses respond instantly. This isn't imagination, it's science. Neuroscientists call this premotor activity, the brain's quiet whisper before the body acts. And now machines can hear that whisper. In other words, your future interface won't just know what you're doing, it'll know what you want to do. While Meta and Apple make headlines, dozens of research labs are already going much further. At the University of California, Berkeley, scientists have built neural decoding systems that reconstruct images from brain activity. They can literally show a rough version of what someone's seeing using AI trained on fMRI scans. At Facebook Reality Labs, teams are experimenting with wearable EEG sensors that can detect language processing in the brain, meaning, in theory, the glasses could one day translate thoughts into words. And in Japan, researchers have combined eye tracking and EEG signals to predict decision-making seconds before a person acts. So while your current smart glasses can't read your mind, the science behind them can. The difference between reading your brainwaves and predicting your next action is getting smaller every year. Let's pause and think about what that means. Your glasses could eventually know when you're tired, when you're lying, what you're curious about, even what you want to buy. Because attention isn't random, it's measurable. Advertisers already use heat maps to track where people look on a screen. But imagine if they had access to where your eyes look in real life. Which brands caught your gaze? Which people made your heartbeat rise? The idea is seductive. Personalized experiences, perfectly tailored ads, a world that understands you. But behind that comfort is something darker. Prediction becomes persuasion. If your glasses know what you'll want before you do, who's really in control? Here's where things get even wilder. Neural interfaces like Meta's EMG band, Neuralink, and CTRL Labs are all part of the same story. They're teaching machines to understand the human nervous system, one signal at a time. Meta's vision is a future where you don't need to speak, tap, or type. You'll simply think, and your intent will trigger an action. It's not telepathy, it's neurocomputing. The technology sits just under the surface of your skin, listening to your neurons as they fire. And when combined with AR glasses, it forms something completely new. A device that doesn't just display information, but shares a language with your brain. Sounds like science fiction until you see how it's already being used. In healthcare, AR glasses paired with neural sensors are helping paralyzed patients regain control over robotic limbs. In defense research, pilots use brain-controlled systems to manage aircraft functions, hands-free. In design labs, artists are creating digital paintings using only their thoughts. Even video game developers are testing emotion-based experiences, where your avatar reacts not to what you press, but to how you feel. It's a new language between humans and machines, and it's rewriting what interaction even means. But here's where excitement turns to anxiety. If your smart glasses can sense what you're focusing on, and your neural band can interpret your intentions, what happens when that data is sold leaked, or manipulated. Think about it. Your emotions become ad data. Your reactions become market predictions. Your attention becomes currency. Even now, privacy laws can't keep up with basic social media tracking. So what happens when your thoughts themselves become data points? Who owns your attention? Who owns your intentions? If we don't set ethical boundaries now, we might trade convenience for control without realizing it. Still, not everything about this future is dark. The same tech that scares us could also set us free. Imagine people with speech disorders communicating effortlessly. Imagine prosthetics that move like real limbs. Imagine creative minds shaping worlds with pure imagination. When we merge human intuition with machine intelligence, we don't lose our humanity, we redefine it. The challenge isn't to stop innovation, it's to make sure we build it responsibly. Because once technology starts reading what's inside our heads, we'll have to decide what we're willing to let it know. Smart glasses that read your mind. It sounds like a headline, but it's becoming a blueprint. The question isn't, can they? It's, should they? Because in the next decade, the most powerful computer won't be in your pocket. It'll be behind your eyes. And whether that's a miracle or a mistake depends on who's wearing them.